Bismillah Rahman Rahim. Today's our topic is lymphoid organ, thymus. Thymus is a bilobe structure situated above the heart behind the sternum and in the superior mediastinum. The origination of the thymus from the endoderm of the third pharyngeal pouch, and the size of thymus is changed in the course of life. At birth, it is around about 10 to 15 grams, and at the puberty age, it is about 30 to 40 gram. And after puberty, a progressive involution occurs to this organ, and it's almost atrophy occur to this organ in the adult. The thymus consists of right and left lobe, which are joined by the connective tissue, and you can see here that this is the one lobe and this is the another lobe of the thymus, and they are joined by the connective tissue. And you can see here that the thymus is located situated in the superior mediastinum. This is thymus, this is the pericardium of the heart, and these are the right and left lungs. The thymus is enclosed by a thin connective tissue capsule. The thymus is capsulated organ, and it has no lymph node in the thymus. No lymph node in the thymus. Okay, remember this, because the spleen has the lymph node follicles, but the thymus has no follicles, no lymph node and this has no afferent lymphatic vessels to the thymus. The thymus is enclosed by a thin connective tissue capsule from which numerous septa extended into the thymus, subdividing two lobes into numerous lobules. Each lobule is divided into a dark peripheral zone that is called cortex and a lighter central zone, the medulla. The medullary tissue is continuous from lobe to lobe throughout each lobe. Reticular cells and macrophages are present in addition to the lymphocytes, which are the dominant cell type within the lobules. And look at this. Look at the picture. This is the capsule of thymus. This is the whole capsule of thymus, and these are the trabeculae, which are extended from the inner side of the capsule. In the parenchyma of the thymus, and divided the parenchyma into lobules, but these lobules are not isolated, but they are connected to each other. Connected to each other, and in the central part of the each lobule has the light staining, which is called the medulla, and outer side is a dark staining, which is called cortex. It is due to the cortex has the most abundant amount of the lymphocytes compared to the medulla, which has the less or few lymphocytes in the center, which is called medulla. Thus, the each lobule is connected with the other lobules, and each lobule has the central pale area, which is called medulla, and the outermost area is the cortex. Which is more darker than the medulla. Lymphocytes are present in both cortex and the medulla, but are more numerous in the cortex, and due to this abundant and the most abundant amount of the lymphocyte, the cortex is stand darker than the medulla, because medulla has the few numbers of the lymphocyte compared to the cortex. Their size are variable in the cortex but are generally small in the medulla. ठीक है, यानी lymphocyte क्या size are variable in the cortex, because when the lymphoblast come from the bone marrow, it is larger in size than the lymphocytes. Lymphoblast is larger in size than the lymphocytes. First, the lymphoblast come into the cortex region of the thymus, and then when they are immune incompetent, they come to the thymus for the education, and therefore the lymphoblast further divided, and it's become differentiated into the lymphocytes, and the lymphocytes come from the cortex and get education and then come to the inner side of the medulla. Majority of these are the developing T lymphocytes called the thymic lymphocyte or thymocytes. यानी इसको हम थाइमिक लिम्फोसाइट्स भी कहते हैं, जो लिम्फोसाइट्स थाइमस में होते हैं इसको थाइमोसाइट्स भी हम कहते हैं. And look at this slide. You can see here these there are lymphocytes and the reticular cells, which are important for the network formation in the parenchyma of the thymus. The thymic lobule contain outer cortex, as I told you, in the inner medulla. The most thymic cells are lymphocytes. Cortex contain rapidly dividing lymphocyte and scattered macrophages. The medulla contain fewer lymphocytes and thymic corpuscles, which are the identification point of the thymus. And this is the slide. This is the slide of thymus, and these are the trabeculae which divide the thymus into the lobules. Trabecules you can see here, and these trabeculae divide the thymic into the lobules, and each lobule has central pale area, and the peripheral is the darker area, the cortex. And you can see here into the medulla it is the pinkish small circle area which is called the Hessel corpuscle. Reticular cells are abundant in the thymus, having eosinophilic cytoplasm and large ovoid lighting staining nuclei, one or more nucleoli. The cells are branched and their slender process are connected with the process of the other reticular cells to form reticulum, cytoreticulum, or cellular network which provides support for the cells of the thymus. And the slide you can see here the reticular cells, and these cells has the long process which are provide form the cytoreticulum which provides support for the cells of thymus. Thymus is a bilobed structure situated above the heart behind the sternum and in the superior mediastinum. The origination of the thymus from the endoderm of the third pharyngeal pouch, and the size of thymus is changed in the course of life. At birth it is around about 10 to 15 grams, and at the puberty age it is about 30 to 40 gram, and after puberty a progressive involution occur to this organ, and it's almost atrophy occur to this organ in the adult. The thymus consists of right and left lobe which are joined by the connective tissue, and you can see here that this is the one lobe and this is the another lobe of the thymus, and they are joined by the connective tissue. And you can see here that the thymus is situated in the superior mediastinum. This is thymus, this is the pericardium of the heart, and these are the right and left lungs. The epithelial reticular cells form the framework of the thymocytes and are of six types. Three located into the cortex and three types are found in the thymic medulla. यानी अगर आप देख लें तो टाइप 1 epithelial reticular cells, type 2 epithelial reticular cells, and the type 3 reticular cells. Epithelial reticular cells are placed in are located into the cortex, and the type 4 epithelial reticular cells, type 5 epithelial reticular cells, and the type 6 are located into the medulla. We are going to discuss one by one. Schematic diagram, you can watch, you can see this, the type 1, the outermost layer of the epithelial reticular cell is the type 1 epithelial reticular cell located in the outer boundary of the thymic cortex and serve to separate it from the connective tissue capsule and trabeculae. And these type 1 epithelial reticulars has the occluding junction, tight junction with each other, tight junction with each other are occluding junction, and also form a sheet around the cortical blood vessels, thus forming blood thymic barrier. ठीक है, तो यहाँ पर हम इनके दरमियान जो जंक्शंस होती हैं इसको हम कहते हैं अक्लूडिंग जंक्शन। इनके दरमियान द एपिथेलियल रेटिकुलर सेल्स होती हैं जो ये हमारे पास ट्रेबिकुलर, एंड दिस ट्रेबिकुली हैज द arterioles and then further divided into the capillary which gives branches toward the cortex and the medulla, and this the lymphocytes which are educating here in the cortex are should be separated from the antigen, should be protected from the antigens which are coming to the thymus through the blood. These are the type 3 epithelial reticular cells. These are are located at the junction of the cortex. This is the cortex and this is the medulla. Between the cortex and the medulla are the type 3 epithelial reticular cells, and cytoplasmic process of adjacent cells are joined by occluding junction. These also has the occluding junction like the type 1, and their main function is to isolate thymic cortex from the medulla, thymic process from the medulla. And the type 4 which are located into the medulla, this is the type 4. These are the type 4 cells. These are the type 4 epithelial reticular cells. These are the type 4 epithelial reticular cells, and are present at the junction of the cortex and the medulla in association with the type 3 cells, joined by the occluding junction with the adjacent type 4 and type 3 cells. यहाँ पर जो टाइप 3 जो टाइप 4 epithelial reticular cells है ये आपस में भी occluding junction बनाते हैं, and also they form the occluding junction with the type 3. तो ये tightly packs यहाँ पर junction बनता है. Both cells assist each other in the formation of the barrier at the corticomedullary junction. The type 5, these are the type 5 cells. These are the type 5 cells, type 5 epithelial reticular cells, and form the cytoreticulum of the medulla. Their nuclei are light staining as compared to the nuclei of the lymphocyte. Cytoplasmic process of adjacent cell are joined by the desmosomes. It also has the type 5 epithelial reticular cell also has desmosome junction. And the type 6, this is the type 6 cells. These are the type cell epithelial reticular cells and form thymic corpuscle, which are spherical or oval structure with eosinophilic cytoplasm and consist of the concentrically arranged type 6 cells having flattened nuclei. The central cells of Hessel corpuscle may be calcified. Exact function is unknown, but there is some evidence suggestive of their role in the T cell education by secreting interleukins. तो ये हमारे पास टाइप 6 सेल्स है जिसके फ्लैट न्यूक्लियाई होते हैं और मे बी कैल्सिफिकेशन पर यहाँ पर होते हैं, और एग्जैक्ट फंक्शन इसका हमें पता नहीं, बट इट टी सेल एजुकेशन रोल अदा करते हैं और ये इंटरल्यूकिन हमारे पास सिक्रीशन करते हैं. तो these are the 6 layer of the epithelial reticular cells from the cortex to the medulla. And in this diagram, schematic diagram, you can see here the capsule, and capsule has the trabeculae extended into the parenchyma and divide the parenchyma into the continuous with each other small lobules पार्टीशन में डिवाइड कर देते हैं. यू कैन सी है थाइमोसाइट्स आर द डेवलपिंग इम्यून आर द lymphocytes are the thymocytes. You can see here the cortico-epithelial cells, blood vessel, dead cells, and the dendritic cells, macrophages, and the medulla and the cortex. और ये एपिथेलियो रेटिकुलर सेल्स है टाइप 1. तो दिस इज द स्ट्रक्चर. और ये हमारे पास डेवलपिंग टी लिम्फोसाइट्स है. और ये यहाँ पर ब्लड आ कैपिलरी वॉल है, यहाँ पर ब्लड आ रहा है. और इन दिस स्ट्रक्चर protect these developing T lymphocytes from the blood which contain the different types of antigen. The function of the thymus is necessary for the developing of the circulating pole of the small, long-lived lymphocytes, the T lymphocyte. These cells are mainly responsible for the cell-mediated part of an immune response. Stem cell invade the cortical region of the thymus where they divide to form the lymphocytes. Only a small fraction, estimately 5% of the cell generated in the cortex leave the thymus. If there is the 100 cells is come for the education in the cortex, only 5% get education and the rest 95% are become dead during education because they become non immune and they are become immune incompetent and they are not get education. जिस तरह स्कूल में 100 बच्चे आते हैं तो 95 निकल जाते हैं और 5 सिर्फ उसमें से 5% एजुकेशन हासिल कर लेते हैं. यहाँ पर भी अगर 100% लिम्फोसाइट्स आते हैं तो 5% ओनली गेट द एजुकेशन, रेस्ट आर बिकम डेड. They migrate via the medulla into the bloodstream to populate the T lymphocyte area of other lymphoid tissue and organ. When they are become educated, इससे हमारे पास टी हेल्पर सेल्स बन जाते, रेगुलेटरी सेल्स बन जाते, साइटोटॉक्सिक इफेक्टर सेल्स बन जाते हैं. देन दे आर माइग्रेट फ्रॉम द मेडुला थ्रू द ब्लड स्ट्रीम टू द secondary lymphoid organs. Cells which don't express the necessary receptor to recognize antigen die and are removed by the cortical macrophages. जो सेल्स एजुकेशन के दौरान डू नॉट एक्सप्रेस द नेसेसरी रिसेप्टर टू रिकॉग्नाइज एंटीजीन, जिसको सेल्फ एंटीजीन दिखा देते हैं और दे कैन नॉट रिकॉग्नाइज, दे आर रिमूव्ड बाय द कॉर्टिकल मैक्रोफेजेस. नेक्स्ट स्लाइड में आपको मैं एक्सप्लेन कर देता हूँ इसको. सिंस द फंक्शन ऑफ द थाइमस इज टू प्रोड्यूस लिम्फोसाइट फॉर द अदर लिम्फोइड टिश्यू, इट इज ए प्राइमरी लिम्फोइड ऑर्गन. ठीक है, तो ये प्राइमरी लिम्फोइड ऑर्गन है. This slide is very important to know how the lymphocytes get education in the cortex. When the thymocytes become from immune incompetent to the immune competent thymocytes, this process is called thymic cell education. And during this education, the thymus cells involved in the expression and deletion of the specific CD markers on the plasma lemma of the T cells. CD markers mean the cluster differentiation markers. The immune incompetent thymocytes have neither T cell receptors nor CD markers on their surface. But when they become educated, immune competent, they express on their plasma lemma the TCR and the CDR. CDR may be CD3, CD4, and the CD8. When a lymphocytes have the both CD4 and CD8 surface marker, we call it double positive stage. As you can see here in this developing lymphocytes, that it has the CD4 and the CD8 both CD marker on their plasma lemma, and like this T lymphocyte we says that it is the double positive stage. And when it have the only CD4 or CD8, we say that these T lymphocytes are the single positive stage. The T lymphocytes get education in the cortex from the endoplasmic epithelial reticular cells type 1 से type 2 type 3 के जब ये cortex में आ रहे होते हैं तो their immune competency are checking through the when these lymphocytes are exposed to the major histocompatibility complex 1 and 2, ये CD4 है और ये CD8 है तो ये if they are CD4 is attached to the major histocompatibility complex 2 and the CD8 are attached to the major histocompatibility complex 1. If they are completely bound and recognize these the major histocompatibility complexes by the CD4 and CD8, we can say that these lymphocytes are getting education are in a proper way, and we can say they are has positive selection. But if this lymphocyte is unable to recognize the major histocompatibility complex 2 and 1, then they are unable to go further and they go to die at this stage. अगर इस स्टेज ये पास कर लें देन दिस लिम्फोसाइट इज गो टू द सेकंड स्टेज और इसकी टेस्टिंग सेल्फ टॉलरेंस की होती है when they are exposed to the self antigen or the self peptide. अगर ये इस सेल्फ पेप्टाइड या सेल्फ एंटीजन को रिकॉग्नाइज करते हैं दे आर देन गोज टू एपोप्टोसिस एंड दे गो टू die because they in the future can develop autoimmune disease. And when they are passing this stage they are going to the other stage where the T lymphocyte have only in the markers surface marker CD4 or CD8. When the T lymphocytes show only the CD4 on their plasma lemma with the TCR, we say these cells are the T helper cells. और अगर if the T lymphocytes show the CD8 with the TCR and then the plasma lemma, we say they are the effector cells or the cytotoxic cells. When they get these education, they are leave in the blood and they goes to the secondary lymphoid organ where they are participate in the defense mechanism of our body.